Good evening, Abhit. Good evening. Good evening. අනිත් අය මොකද දන්නේ තාමනේ තවලා තියෙනන්නේ. අපි මොකද කරන්නේ මේ දවස්වල? සබ්ජෙක්ට්ස් තුනේම වැඩ ගෙරිගෙන යනවාද? එතකොට මේ මැත්ස්වල ගණන් හදනවානේ නේ. ඔයගොල්ලෝගේ රිවිෂන් වැඩ තමයි මට හිතන්නේ කොහොමද මේ තත්ත්වය තව මාස දෙකක් පවතින එක නැහැ. අපිට පන්ති පටන් ගන්න පුළුවන් වෙයි. දැන් ඉතින් එක්කවර කොරෝනා වැක්සින් එක හරි මොකද්ද සිංහල වේද උත්සාහගත කියනවානේ. ඒ මොනවාරි දෙන්න ගත්තන් පස්සේ මේ තත්ත්වය වෙනස් වෙයි. එතකොට මේ අපිට කලුත් වැඩ පිළිවෙලකට යන්න. Okay, so let's start with. Last day we discussed two cases to integrate functions of the form 1 over a quadratic ax squared plus bx plus c. We discussed how to solve this type of problems. Are you with me? Good evening, with me. And also we discussed 1 over how to solve a problem like 1 over ax squared plus bx plus c with square root. How to integrate a function like this also, right? With that, we finished some part in integration, and today we are going to start another important section in integration, right? That is how to integrate rational functions, right? This is something very important in integration. And it's a big topic in integration, right? Integrating rational functions. Integration of rational functions. Right. Rational functions, we don't need to introduce rational functions here. This is something we have discussed some long ago. Uh, we did even partial fractions at the very beginning. You need partial fractions today in this. Uh, so rational functions, you know that can spread in a very vast range, right? A rational function, it can be something like this, some linear 1 over quadratic. For example, or it can be a linear 1 over another linear, or it can be a quadratic over linear 1. Or it can be a quadratic over cubic function. So likewise, many other types I can write. So these rational functions fall in a vast range, right? Very different type of rational functions you can see: linear or, over a quadratic, linear over linear, a linear over cubic, a quadratic over a linear. It can be a cubic function over a linear, cubic function over quadratic, a cubic function over another cubic function. Likewise, very different type of rational functions. You can see uh, a different type of rational functions, right? Now, the thing is how to integrate rational functions. So because you find very different type of rational functions, can you, what do you think? Can you give some single unique method, single method to integrate all the rational functions? What do you think? Do you expect to learn one method matching to all rational functions? Hmm? So it is not so, right? The integration, you see, integrating methods are depending upon uh, the function we see, right? Many, so it's like a methods based lesson we are learning here to integrate this type of function. This is the method to integrate this type of function. This is the method. Likewise, we are learning methods in this section. So to integrate these different types of rational functions, you can't expect to have a single method, right? Uh, but basically we consider rational functions in two cases, as we have done in earlier in partial fractions also, we started dividing rational functions into two cases: proper rational functions and improper rational functions. Right here also we first consider proper rational functions. After that we can go to improper rational functions. So first start by integration of integration of proper rational functions. Better we write at the beginning. Write it at the beginning in this section. In this section, we consider the following two cases. Separately. What are the two cases? Number one, proper rational functions or integration of proper rational functions. functions, then we will come to integration of improper rational functions. Right, so we start with the first integration of proper rational functions. Again, as I said earlier, there is no single method, right? Just to follow. Instead, we'll use some procedure. If it's the proper rational function, we first try this. If not succeed, you can go to another one, have another try. There's another method. If it also fails, you can go to another one, right? Likewise, we have some procedure because there is no single method. Hmm? Uh, okay, we start with this. Shall I name them one A and B? We start by A, integration of proper rational functions. Now, if it looks, the problem looks like this. To integrate, to solve the problem, an integration problem, integral of dx over qx. So that a rational function, right? Proper rational function means the degree of the numerator px is less than degree of the denominator qx, right? Degree of px is less than degree of qx. That's what they are considering here. Integration of proper rational functions. Good evening, Sachin. Uh, so, if it's a proper rational function to integrate, the first thing we do, right? First thing we try is check if you can create the derivative of the denominator. Create the derivative of qx in the numerator in px at once, right? Without effort, easily. If you can easily at once create the derivative of the denominator in the numerator, so we will use that to integrate, right? We will iterate it that way. Okay, so I will write in simple A, if the derivative of qx can be created in dx, we will integrate using that. If you can do it easily only, if you can do it easily, then only we will go to that option. Example, you have to integrate x cube dx over x to the power 4 minus 1. So this is the task. To integrate x cube dx over x to the power 4 minus 1. You got some idea? Any idea? To integrate this? What do you do? X cube over x to the power 4 minus 1. What do we do to integrate this? It's very easy, one step. Yeah, it's something very easy. Hmm? No idea. To integrate this, you should see it. It takes only 3 4 seconds to finish it. Give the complete answer. What do you do? X cube over x to the power 4 minus 1. Oh, කවුද ඉන්නේ? අභීත ඉන්නවා, සචින් ඉන්නවා, යුක්මී මොකද කරන්නේ? ඒ මොකද ළමයි? You have no idea? Hmm. This is something you can do very easily. Here, x to the power 4 minus 1. What is the derivative of this? Derivative of the denominator is? Yeah. Yeah, yeah, answer is correct, Abhita, but I expected a much simple one. But how to do that? Hmm? Only to, so it's a derivative is 4x cubed. Just to multiply and divide by 4. That's what I expected. Hmm? Just multiply and divide by 4. Within seconds you can do. You can write 104 4x cubed dx over x to the power 4 minus 1. Multiplied and divided by 4 to create the derivative in the numerator. Now 104, you see the derivative in the numerator, it's ln form, ln mod of x to the power 4 minus 1 plus c. Right? So once you can do it like this within seconds, so you don't have to go to another option, right? This is the best thing to do if possible, right? If it's not possible, then what do we do? Okay, we'll come to that after this. So you just take it down, then we will see what if this is not possible. What are the other options that we have? Okay. Okay, we can come to that. As I said, this is a bit of complicated problem we are touching today. Integration of rational functions. It's a complicated topic because rational functions are very different types. So we have to find methods of to integrate different types of rational functions, the different problems. Hmm? Okay, just take it down, then we can go to another one. ළමයි මට මතක විදියට මං ගිය සති කිව්වා ඔයගලන්ට බලලා තියාගන්න කියලා නේද partial fractions කිව්වා වගේ මට මතකයක් තියෙනවා. Okay, now we are in proper rational functions. If you can do this, if you can create the derivative of the denominator in the numerator by one step, in a single step easily, so we will iterate using that. But this is something that you can't do always, right? What if not? If this is not possible, then what is the next step? Then what do we do? Hmm? Next option. If not possible, if it is not possible, then we will see if you can break it into partial fractions, right? Try partial fractions. If this is not possible, our next option is partial fractions. If it is not possible, then see if partial fractions can be used. How to decide that? Or if you just check if you can break the function into partial fractions. But how to decide that? How do you decide whether you can use it or not? Break it into parts of partial fractions or not? Hmm? To check if a function can be broken into partial fractions or not, so it depends upon whether the denominator of the function, the rational function, has factors or not. If you can factorize the denominator, that means you can break it into parts. If the denominator cannot be factorized, that means you cannot break it into partial fractions, right? Uh, so in other words, if you see denominators in the factors in the denominator, then you will use partial fractions. But you go to this option at once. You first try the first method, right? A. Only if it is not possible, you go to B, because that method is easier if you can apply it, right? Partial fractions. But here I will give a few examples. You should remember the techniques of partial fractions also. I'll show one example. One to integrate something like say 2x plus 5 over x minus 1 into 3x plus 2. This is the problem. Answer is answer is, you can easily see that it is like 3x squared plus x minus 2 the denominator. You can't at once create the derivative of the denominator in the numerator, right? Here it is not possible. So we have to go to the second option, partial fractions. So we will find partial fractions first. You get marks separately to finding partial fractions. Find partial fractions of this 2x plus 5 over x minus 1 into 3x plus 2. Do you remember how we break it into parts? It's broken as a over x minus 1 plus b over 3x plus 2. Right? So equating the numerators, 2x plus 5 equals a into 3x plus 2 plus b into x minus 1. You can find b just setting x at 1. You can find a just setting x at 1. You can find b setting x at minus 2 over 3, right? So when x equals 1, you get x equals 1, this disappears. 5a equals 7. A will be equal to 7 over 5. Then apply x equals minus 2 over 3. Minus 2 over 3, that will be minus 2 over 3 into 2 plus 5 equals, right, it's b into minus 2 over 3 minus 1. So it's 15 minus 4, 11. B equals minus 11 over minus 11 over 5. B equals, I write it here. You get like B equals minus 11 over 5. Yeah. B equals minus 11 over 5. Right? Now partial fractions are, we'll substitute them here. So by 1 you get, substituting in 1, 2x plus 5 over x minus 1 into 3x plus 2 is equal to a is 7 over 5 over x minus 1 plus b is minus 11 over 5 over 3x plus 2. So this side is equal to this side. We have broken it into partial fractions. This side is equal to this side. Therefore, the integral of this equals integral of the other side. So integral of 2x plus 5 dx over x minus 1 into 3x plus 2 equals, you can take the constant 7 over 5 out, integral dx over x minus 1 minus, you can take the constant 11 over 5 out, dx over 3x plus 2. Right? So these are functions which can be integrated easily. 7 over 5 ln mod of x minus 1 minus 11 over 5 ln mod of 3x plus 2. You have to further divide by 3, right? So that will make it 15 here. And plus c is the answer. So that's how we use partial fractions to integrate a rational function if that a is not possible, right? Okay, take it down. I like few more examples here that you have to do them. Hmm? හරි ගණන් ටික හදාගෙන යන්න මම ටිකක් වෙලා දෙන්නම් සම්මිලිත කරන්න ඕන ළමයි කරගෙන යන්න. මම වෙලා දෙන්නම් තරම් හදාගෙන යන්න. So let's see answers of one or two of them. You have to start it properly, breaking into parts like this. X plus 1 plus c over x plus 1 square. Equal to numerators. So x equals minus 1 gives 2 here. Plus c into x minus 3 equals c times minus 1 is minus 5. C equals to minus 2 over 5. X equals 3 over 2 will give 9 over 4 plus 1 will be 13 over 4. On the other side, a into 3 over 2 plus 1 square. So there will be 25 over 4. So a is equal to 13 over 25. So that's how we can get by substitutions. Then we have to use coefficients. Let's equate the highest power x square. X square terms you get a plus b, a plus 2b rather. A plus 2b equals 1. We have the value of a. So 2b equals 1 minus a. 13 over 25. That will be 12 over 25 divided by 2. 6 over 25. So these are the partial fractions. So we found the coefficients. Now substituting, you get x squared plus 1 dx over 2x minus 3 x plus 1 squared is equal to a is 1305. Let's take it out. Integral of dx over 2x minus 3 plus b. b is 6 over 25. Taking it out. Integral of dx over plus 1, then plus c. C is minus 2 over 5 dx over x plus 1 square. Now you can give the final answer. I like these questions here. I'm writing these two questions again. So 13 over 5. This is ln mod of 2x minus 3 integrating this. But it is 2 here, so you have to divide further by 2. So it will be changed to 10. Here also the same. Plus 6 over 25 ln form mod of x plus 1 minus 2 over 5. This is 1 over x plus 1 square. You have to take it to top as x plus 1 to the power minus 2. Then you iterate at 1, that will change to minus 1. So x plus 2 to the power minus 1, that will be 1 over x plus 1, 1 over x plus 1. You have to divide further by minus 1. That will change the sign here in the middle. So plus 2 over 5, 1 over x plus 1, finally plus c. So this is the answer for part 2. අලුත් වැරදි තියෙනවා නම් හදාගන්න part 2. අන්තිමට වෙලා දෙන්න before going to part 3. බලන්න අඩුපාඩු තියෙනවද කියලා තියෙනවා නම් හදාගන්න. So I'll go to number 3. Number 3, the last part, you will is the problem. The last part I'll explain that. Last part of 3, right? So this is something you cannot break further. Its delta is less than 0. No further factors of this. So it's a quadratic factor. So you have to break it like this: a over x minus 3. If it's a quadratic factor, x squared plus 6 plus 1, of which there are no factors, so the linear factors. So you will write the linear one on top, bx plus c. That's how you start. ඕවා මතක කරලා නැතුව ඇති නේද ළමයි? මුල් කාලේ කොහොමද ඉගෙනුවා? ඕවා ගණන් ගලුවා. Equal numerators 2x squared plus 3 equals a into x squared plus 6 plus 1 plus bx plus c into x minus 3. So you can apply x equals 3. That will be 9, 18, 21. A is equal to 21 divided by 9, 10, 13. 21 or 13. No more values to substitute. You have to equate coefficients there onwards. So we'll take x square terms. X square terms give a plus b equals 2. So b equals 2 minus a. 21 over 13. So that will be 5 over 13. 5 over 13. Yeah, then we can go to constants. Constants and do a minus 3c equals 3. So 3c equals a. A is 21 over 13 minus 3. You can divide everything by 3. C is equal to 7 minus 3, 4 over 3. Not. It's 13. Anyway, then 7 minus 13. 7 minus 13. That will be minus 6 over 13. C will be equal to minus 6 over 13. These are the values I got for A, B, and C. You can check the answers. A is 21 over 13. B is 5 over 13. What I got for C is minus 6 over 13. Yeah. Now back to integration. So integral of 2x squared plus 3 over x minus 3 into x squared plus 6 plus 1 dx equals a. A is 21 over 13 over dx over x minus 3 plus bx plus c. b is 5 over 13. b is 5 over 13 x. c is minus 6 over 13 over x squared plus 6 plus 1 dx. This you can easily iterate. 21 over 13. This is ln mod x minus 3 plus, if you want, you can take 1 over 13 out of the integral of this one. So that will give 1 over 13. මෙතන පොඩි ප්‍රශ්නයක් තියෙනවා මම බලා ගන්න. 1 over 13 integral of 5x minus 6 over x squared plus 6 plus 1 dx. බලන්නකො ලොකන්ට නිකන් ආවද කියලා ඉස්සෙල්ලා. Check if you have this, came up to this, or any doubt? Right, then the thing is how to integrate this. This is again a rational function, right? Look at this. This is again a rational function. And how to integrate this? So far we learned only two methods. Number one, to integrate rational functions, proper rational functions. This is a proper rational function. The first thing, you check if you can create the derivative of the denominator in the numerator at once, right? At once, it is not possible here. Derivative of the denominator is 2x plus 1. So you can't create it here at once, right? You will get some other terms. Then you check if you can break it into partial fractions. But can you do so? The second method, if the first method fails, you check if you can break it into partial fractions. But here, this time, it is also not possible. To break into partial fractions, there should be factors in the denominator. But here, there are no factors. So you can't break it into partial fractions. Therefore, both our methods failed here. So we have to find some other option. Right, දැන්ට මේක ස්ටාර් එකක් දාලා තියාගමු. That's what we are going to discuss next. මේක කොහොමද තියාගමු. It will be discussed later. දැනට අපි දන්න විදිහට කරන්න බෑ. ඔයගොල්ලෝ ගණන් හදුවා නම් you should have faced this problem. How to integrate this? So we'll come to that after a while. Before that, we have to do the fourth also. Okay, leave it for a while, then go to the fourth. Because we can't integrate the two methods any of the two methods that we have discussed so far. We need something different there. Okay, leave it there and go to the fourth. Shall we go to the last? Now, keeping this in mind for a while, we go to the fourth, fourth and last. Power 4 minus 1. Now, before breaking this into partial fractions, you have to break the denominator into factors. Factorize the denominator. Then only you can see how you break the function into partial fractions. Factors are x minus 1, x plus 1 and x square plus 1. You first write it as x square minus 1 into difference of squares. Difference of squares, x square minus 1 into x square plus 1. Then this can further be broken, x minus 1 into x plus 1. Right? Uh, so now you can make it like a over x minus 1 plus b over x plus 1. This is a quadratic factor of which there are no further linear factors. This one. So it has to be written as cx plus d over x squared plus 1. So equating numerators, you get like x squared plus 2 equals a into x plus 1 into x squared plus 1 plus b into x minus 1 plus x squared plus 1 plus cx plus d into x minus 1 into x plus 1. X minus 1 into x plus 1. So apply x equal 1, you get one answer. X equal 1 will give a equals 3 over, when x is 1, 3, 3 over 4. When x equals minus 1 will give the value of b. B equals again 3 over minus 2 plus 2, minus 4, minus 3 over 4. Yeah. Then equate x square. No more is to substitute, you have to equate coefficients. Then x square terms will give, no, x square will go to x cube, the highest. My advice was to go to the highest power. So it's x cube, a plus b further plus c. Yeah. Plus c. Yeah. Plus c equals no x cube term on the other side. It's 0. So this gives a plus b. 304 minus 304 plus c equals 0. So c is equal to 0. C equals 0. We need to find d further. for which we go to constants. Constants, on right constants you get by setting x equals 0, will be a when x is 0, you get a minus b minus d equals constant on the other side is 2. So d equals a is 304 minus b is again plus 304 minus 2. So it's minus 204 minus half. Minus 1 over 4. Right? Yes, now partial fractions are x squared plus 2. So it will be a over x minus 1, a is 304, x squared plus 2 over. We iterate at once, x squared plus 2 over x to the power 4 minus 1, integral of that equals a is 304, integral of dx over x minus 1 plus b is minus 304, it can be taken out, that constant, taken out, dx over x plus 1 plus c0, then it is just d. D is minus half. So minus half over x squared plus 1. So iterating, you get 3 over 4, 1 over x minus 1. It is ln mod of x minus 1 minus 3 over 4, 1 over x plus 1. The integral is ln mod of x plus 1 minus half 1 over x square plus 1. Takala matak වෙන්න ඕනේ. 1 over x square plus 1, it is tan inverse. The last day or the day before, right? We learned it. 1 over x square plus 1 is tan inverse x. Straight away it is tan inverse x plus c. One more step. You can from these two you can take 3 over 4 out. If you take 3 over 4 out, then will be ln minus ln. So ln minus ln, you can give it as a division. Lastly, also I remember we discussed these things. If you take 3 over out of these two, that will give ln mod of x minus 1 over x plus 1 minus half tan inverse x plus c. So this is the answer. බලන්න ඕගොල්ලෝගේ අඩුපාඩු තියෙනවා නම් හදාගන්න. චෙක් කරලා බලන්න ආන්සර්ස් හරිද කියලා. හරිද ළමයි? ඔයගොල්ලෝ ඉවර කරමු. කවුද ඉන්නේ? කීප දෙනෙක් ඉන්නේ? අභීත් ඉන්නවා මම හිතන්නේ. සචින්. තව කවුද? යුක්මි ඉන්නවද? කවුරු හරි තව ඉන්නවා. Done it? If so, we can go to the next topic. Next method. C. This is B. We can go to C. ඉවර නම් කියන්න. හදිසියක් නැහැ. ඔයගොල්ලෝ තාම කරගෙන යනවා. I can give time. ඉවර වුණාම කියන්නකෝ. ඉවර නම් කියන්න ළමයි. තාම ඉවර නැද්ද? කට්ටිය. Are we the finished? Whatever the others? You now can. Nitya family ada. Kau dinaya hanit kati family ada. Kana ada. Apa yang kamu dah hilang ke kata? No response. Okay, we go to then C, right? Still we are in proper rational functions, integrating proper rational functions. So we first said first check if this is what we have to integrate. If the derivative of the denominator can be created in the numerator at once, so we will use that to integrate, right? Then we said if not possible, we said try partial fractions. Partial fractions, then how do we decide that we can go for partial fractions? It is by checking the denominator, qx. If there are factors in the denominator, you can break the function into partial fractions, right? So if this is also not possible, we have seen in example 3, the last part, we have seen there are cases uh, this is also not possible. It's not coming under this. It's not coming under this also, right? Then what do we do? If this is also not possible, then C. We are in C. If B is also not possible. Not possible. We have one more chance, right? We have one more chance to check if the denominator is degree quadratic, right? One more chance. If the first and second both fail, we check if the denominator is quadratic and the numerator is linear, right? This is the last chance that we have. And if the denominator is quadratic and the numerator is linear, again we can, maybe not at once, after some effort, if the denominator is quadratic, numerator is linear, we can not at once, but we can still create the derivative of the denominator in the numerator. There will be some remaining terms also, right? So that's what we do. Again, මුලදී කිව්වා වගේම in A, we create the derivative of the denominator in the numerator, but maybe not easily, not at once. So there are some problems still to be solved. Mhm. We create the derivative of the denominator in the numerator. Right, some example. Make a color. Right. As example, you have something like this. Say 3x plus 4 over x squared plus 6 plus 1 dx. Right? Now look at this. It's not coming under the first. So derivative of the denominator is 2x plus 1. You can't create it at once, right? Easily here. If not, you check if you have, you can break it into partial fractions. But here it is not possible. This can't be broken into partial fractions because there are no linear factors in this denominator. So then we have to again back to the first option. You have to create the derivative of the denominator in the numerator, right? So in this denominator is equal to x squared plus x plus 1. Derivative of the denominator is 2x plus 1. මේක ලියන්න ඕනේ නැහැ මම නිකන් ලියුවේ. Only for the first example you can write it down, but not for the others. It's not necessary. Then 2x plus 1 is the derivative of the denominator. We need it here in the numerator. So we are going to create this derivative in the numerator. We will just write it. So answer. So we want to see 2x plus 1 in the numerator. We want it, so we write it. In the numerator, we want to see 2x plus 1. So we'll just write it. You want 2x plus 1, so you write 2x plus 1. Then check if the two sides are the same. So they are not. They are not. Here it is 3x plus 4, here it is 2x plus 1. So we have to make them equal. We have to balance them. First balance the x power, x term, the highest power term x. 3x here, you are given 3x, but you have written 2x. To balance them, you will have to introduce 3 over 2. 3 over 2 here in front of 3 over 2. Writing 3 over 2, you can equate the x terms, right? You can equate the x terms, writing 3 over 2, so the 2 will get cancelled. It's 3x. X terms are okay now. Here the constant. Now you have 3 over 2 as the constant, but you are given 4. It has to be 4 here. We have written only 3 over 2. But to make them equal, so is it enough to write like 4, 9 equal to 5 over 2, number 32. If you write 5 over 2 there, highlight it here. Okay. Yeah. Now 3 over 2 plus 5 over 2, that will give 4. Now two sides are the same. Now to get some use of this, we have the derivative of the denominator in the numerator, right? To make some use of that, we will have to take them separately. This part separately and this part separately. If you take this part separately, we can use the fact that this is the derivative of the denominator. So we will break it into two. Equal to, I take 3 over 2 out. Two x plus 1 over x squared plus 6 plus 1 dx. Then plus 5 over 2 taken out. Then plus 5 over 2 taken out. It is dx over x squared plus 6 plus 1. Sorry. This part, you have some function here and its derivative of So at once you can write the integral of this. So that part is easy. That's ln. 302 is outside. Ln mod of the denominator. Then what about this? Here you have 1 over a quadratic. So this is something we learned last day. 1 over quadratic. Whatever the quadratic, we can solve it. Last day we learned, right? Here what is special about this is delta is less than 0. Do you remember last day we learned if delta is less than 0, we will uh, complete the square. We will complete the square of the denominator. Yes, අපි ඉගෙන ගත්තා. Here it is delta is less than 0 case. So the denominator is the expression in the denominator. We will complete the square in the denominator. X plus half squared plus 1 minus 1 over 4. So that will give you plus 3 over 4. We have already integrated it. So it's 3 over 2 ln mod of x squared plus x plus 1 plus 5 over 2. Make this is something we learned last day. This is of the form, the integral. This is the tan inverse form, right? Do you remember? This is the tan inverse form. 1 over a, this is a squared. 1 over a is 2 over root 3. 2 over root 3 tan inverse x instead of x we have x plus half here. Multiplied by root of this, so that is 2 over root 3 again. This whole part is between brackets, the angle, not angle, tan inverse value. මේක ටිකක් simplify කරන්න පුළුවන්. මට මෙතන හිතේ තියෙනවා වගේ නේ. The final answer ඉතුරු ටික අතර ඔයගොල්ලන්ට හොයා ගන්න පුළුවන්. I'll try to write it here. So it's 3 over 2 and then mod of x squared plus 6 plus 1 plus mechanism 5 over root 3 tan inverse lian itu teman-teman. Tan inverse mechanism dekat kapelon 2x plus 1 over root 3 plus c. Don't forget to write plus c. තේරුණාද ළමයි? ඔය මතක් වෙන්න ඕන ගණන් හදනකොට, right? If you have something like a quadratic over a linear over quadratic, if you have no factors here, then this is the option you have. You will create the derivative of this denominator in the numerator. Then once you create the derivative of the denominator in the numerator, you will get some constant here, plus a constant. So we will separate them into two parts. The first part is easy, it's ln form. The second part, there you will have to complete the square, and that will give you something, the tan inverse form that we learned last week, right? Okay, ලියාගන්න මම තව එක ගානක් විතර දෙන්නම්. අපි හදමු. අර මම මුලදිත් කිව්වා වගේ ළමයි මේ ඉන්ටිග්‍රේෂන් පාඩම අමාරු නෑ හොඳේ. Once something is explained, some method is introduced, you can easily understand. But the thing is, there's a lot of methods. You should remember. මේව තේරුණාද නැද්ද කියලා මම හිතන්නේ අහන්න ඕනෙත් නැහැ. Anybody can easily understand these things. Main thing is you should remember once you are given some function to integrate, you should remember these methods, techniques. Shall I write the second question? You first finish this, then try. I'll write the second. Second example. ඔයගොල්ලෝ මේ හරි ලියපුවා පේනවද? පේන්නේ නැත්නම් මම ආයෙ ලියන්න. මේ හරි ලියන්න. නැත්නම් මට මෙහෙම කරලා ලියන්න පුළුවන්. I can do that. I can rewrite it. The last line. I take this place also. The last line is this. Thank you very much. You can go to the next. මම ටිකක් වෙලා දෙන්නම් තනියම කරන්න. Here the derivative is 4x plus 3. 4x plus 3 to make them equal. I write 3 over 4 here. Derivative of the denominator is 4x plus 3. I wrote it in the numerator. We have to balance two sides and just wrote 3 over 4. So x terms are equal. Then I have written 9 over 4 as a constant, 9 over 4, but we need minus 5. To make it minus 5, so we have to write another, like 29 over 4 minus 29 over 4, that one together. So that will be equal to minus 20 over 4 minus 5. So I'll write minus 29 over 4. Now I can break it into two parts. This part separately and this part separately. Three or four will be taken out at the same time. Minus 29 over 4 will be taken out. Now this part is easy. You easily see the derivative on top. So the integral is 3 over 4 ln mod of the denominator plus, minus 29 over 4. Here we have to complete the square because delta is less than 0, a quadratic in the denominator. With delta less than 0, we have to complete the square, for which we will take 2 out. First, so that will make it 8 here. Taking 2 out, we will make it 8 here, and we get x squared plus 3 over 4x plus 2. Yeah. So 3 over 4 and then mod of 2x squared plus 3x plus 4 minus 29 over 8 integral. Then complete the square. W3, sorry, x plus 3 over 4 squared. So minus 9 over 16 plus 2. Minus 9 over 16 plus 2. That is 32 minus 9 plus 23 over 16. That's what we get completing the square. And now this is tan inverse form. So 3 over 4 ln mod 2x squared plus 3x plus 4 minus 29 over 8. This is tan inverse into 4 over root 23 tan inverse x plus 3 over 4 into 4 over root of 23 plus c. එක step එක සුළු කරන්න පුළුවන්. You can simplify this. සුළු කරලා ලියන්න. තව step එකක් simplify කරලා ලියන්න. One more. Let's simplify a bit more. බලන්න අඩුපාඩු තියෙනවා නම් හදාගන්න. මම විනාඩි කිහිපයක් දෙන්නම්. Hari. So that's all about proper rational functions, integrating proper rational functions. Now we can go to the next, improper rational functions. Hmm? How to integrate improper. Now අපි කිව්වා a b c තුනක් හොඳේ. A, if the derivative can of for proper rational functions, if the derivative of the denominator can be created in the numerator at once, we integrate using that. If not, you try partial fractions. Again, if not possible, then with some effort, maybe we create the derivative of the denominator in the numerator, but only when the denominator is quadratic and numerator is linear. So, එහෙමත් කරන්න බැරි නම් එක දෙයයි අපිට ඉතුරු, if it's a proper rational function, you can't work out with any of these methods. එක දෙයයි කරන් තියෙන්නේ ගාන දීපු මිනිහටම හදාගන්න කියලා ඉතුරු කරන්නයි වෙන්නේ. මොකද A level පන්තියේදී අපි සීමිත ප්‍රමාණයක් තමයි ඉගෙන ගන්නේ. හරි. A level පන්තියෙන් එහාට ඉගෙන ගන්න ගියොත් ඔයගොල්ලන්ට තව ඉතින් දැන් මේ කරන්න දැනට කරන්න බැරි තව දේවල් ඉන්ටිග්‍රේෂන් යම් ප්‍රමාණයක් ඉගෙන ගන්න පුළුවන්. එහෙම කරන්නත් බැරි ඒවාත් තියෙනවා. හරි. Okay. So that's all about proper rational functions, integrating the proper rational functions. Now we go to improper rational functions. Not much to write in that as a note, only one sentence. Right? In short, if it's an improper rational function, only thing we do use partial fractions. Right? Break it into partial fraction. That's all we have to write. The rest is will be explained with examples. Right? B, integrating improper rational functions. Right. How to integrate improper rational functions? Only one sentence we write. We use partial fractions. There are ways of writing partial fractions for improper rational functions. Finding partial fractions of an improper rational function is somewhat different to the proper ones. Example, we take a simple example. Say 3x plus 5 over 2x minus 1 dx. So it's an improper rational function, the same degree, denominator and numerator of the same degree. I taught you a simple method of finding partial fractions of these improper rational functions. ඒක දාන්න. එහෙම නැත්නම් අර සම්මත හැමෝම කියන විදිහක් තියෙනවා. අපි ඒ විදිහටම කරලා බලමු. Partial fractions. අපි මේ තාම කරන්නේ ළමයි මේ අවුරුදු අර 100 ගානක් පරණ මෙතඩ් ගොඩක් අය පාවිච්චි කරනවා. So the quick method I taught you is this: use long division, not something to really new, but it's very easy. I don't know why this is used much. So it's 3 over 2 long division. You get 3x minus 3 over 2. That will be 7 over 2. If you use the long division, I write it again here. It is 13 over 2. Currently divided in 13 over 2. So these are the partial. So we can use this to find partial fractions. 3x plus 5 division algorithm divided by 2x minus 1. Denominator is quotient is 3 over 2 plus the remainder is 13 over 2. Now divide by this, you get 3x plus 5 over 2x minus 1 equals 3 over 2 plus 13 over 2. 13 over 2 times 2x minus 1. These are the partial fractions. අර අනිත් විදිය ගොඩක් වෙලාවට ඉස්කෝලේදී එහෙම කියලා දෙන්නේ නැත්නම් මෙහෙම ඕන මෙහෙමත් කරන්න පුළුවන්. අයිතන් මම කියන විදිය දෙසි. Second method if they are of the same degree, you start making some constant plus another constant over 2x minus 1. Breaking this into partial fractions, you get a constant plus another constant over 2x minus 1. If you want to pattern, you write a constant plus method linear. This is the linear one. From b over 2x minus 1. Then find a and b. To find a and b, सामान्य विधि में we equate the numerators a 2x minus 1 plus b. Okay, simplify कराना a equals 3 over 2, b equals 13 over 2. Oh, so make partial fraction same way now, right? In this method also. So you can use them. You can use them to integrate the function. Basically, I will go mathematics. I'll explain. I'll do it again. So second method. Okay, first we have to finish this problem answer, then we'll go to a few more. integral of this, we found a and b. Integral of this equals integral of this. Equals 3 over 2 integral of dx, taking in two parts. 13 over 2 integral of dx over 2x minus 1. So finally, it is equal to 3 over 2x. Integrating this, you get x plus 13 over 2 integral of this. It's ln mod of 2x minus 1. You have to divide further by 2 because it's 2x here. Then make it 4 plus c. Finally, this is the answer. අපිට තව examples කරන්න වෙලා මදි ළමයි මේකට improper rational functions මම එක අනිත් දවසේ කරන්නම් තව examples කීපයක් but for the moment you can try for homework you can try some from proper rational functions. There is, in the tutorial I have given sent to the group exercise B. Homework exercise B, but not all. In exercise B, do proper rational functions problem. Only the proper parts, proper rational function part. Improper ඒවා කරන්න යන්න එපා. මොකද මම තව examples ටික කරලා පෙන්නන්න. ඇත්තටම පෙන්නන්න ඕනෙත් නැහැ. මොකද මේ integration මොනවාද partial fractions හොයලානේ තියෙන්නේ improper ඒවට. ඒක කෙලින්ම දාන්න තියෙන්නේ. ඔයගොල්ලන්ට කරන්න නම් පුළුවන් සම්පූර්ණ exercise එක. දැන් ඔන්න කරන්න සම්පූර්ණ එක. Anyway, next day I will show one or two more examples for improper rational functions. එහෙමනම් ළමයි homework ka totally yaadana, right? Exercise D in the tutorial. Exercise D. At least do all the proper rational function parts, but you can try the rest also, right? But to do all the problems in that. එහෙනම් ඔතනින් නවත්තමු ළමයි අදට. ඉරිදට අපි applied maths පන්ති. ඔයගොල්ලෝ හැමෝටම good night.